Assalamualaikum warahmatullahi wabarakatuh. My name is Nurin Batrisha binti Abdul Aziz and I'm from CS2493B2. So I'm going to present my lab assignment using Maple. So for section A, I choose question D. So the first thing that we need to do is we need to restart. And then with open bracket plots, close bracket and semicolon. For this question, I use implicit plot 3D. So I type implicit plot 3D, open bracket, and we will put the question which is x squared plus 4y squared plus 9z squared equals to 36. And for the limits of variable, we assume for x, y, and z is -7 to 7. Therefore, the image that we will get is this one for the limit -7 to 7. Next, we want to test with another limits of variable. And so implicit plot 3D, open bracket x squared plus 4y squared plus 9z squared equals to 36. And now we assume that x, y, z has the limit from -12 to 12. Then we will get the image of the variables is this. So from the figure that we get from the command, this and this one, we can conclude that the name of the surface is ellipsoid. Next, the question that I choose is question F. So just like before, we put restart and then with plots. So this question, I also use implicit plot 3D, open bracket, and we will put the question that we already have, which is x power of 1 minus y squared minus z squared equals to 1. Now we assume that x, y, and z is -2 to 2. Therefore, we will get the figure like this. We want to test the equation with another limits of variable. So implicit plot 3D, open bracket, and put the equation where we assume that the limit of x, y, z is from -10 to 10. Therefore, we will get the figure like this. Hence, we can conclude that from this figure and the figure with the limits of -2 to 2, that the name of the surface is elliptic paraboloid. Now, I'll show you the section B of question 1 coding. First, we restart and then with plots and then we insert the question that was given to us, which is the cone square root of x squared plus y squared and the plane is z equals to 4. Then to get this one, we go to insert and plot 3D. After that, we only get a box. To get these surfaces inside the box, we copy this and we drag it into the box. That is why we get this one. Now we name this surface as cones equal to plot 3D, open bracket, rho, theta, and pi over 4. This phi is pi over 4 because we know that spherical for cone is pi over 4 for phi. So rho is equal to 0 to 4 second pi over 4. Theta is equal to -pi to pi. Chords is spherical and I choose the color equal to light pink because it will make it easier for us to differentiate it later. So this is the image of cones that will come out from this command. Now we want to do the plane. So plane equal to plot 3D, open bracket 4 second phi, theta is equal to -pi to pi, phi is equal to 0 to pi over 4, chords is equal to spherical and color is the light blue. Therefore, we will get the plane here like this. So now we want to display it. So we use plots, display, cones, planes, viewpoint is circle right. Then we will get this figure where down here is the plane and this is the cone. So this is the solid that we will get from question 1. The next question that I choose is question 3. Just like before, we restart and with plots. Then we put the command hemisphere equals to sphere plot, open bracket, 5, theta, phi. R is 5 because the radius for hemisphere that we get from the equation is 5. Theta is negative pi to pi. Phi is 0 to pi over 4. This is pi over 4 because hemisphere is half of sphere. And the axis equals to box. And then we will get this figure. Then we want to do the cylinder, where cylinder equal to cylinder plot, open bracket, 2 theta z. This is 2 because from the equation, we know that radius is equal to 2. Theta is 0 to 2 pi because it is a cylinder. Z is equal to 0 to 5 and the axis is equal to box. So we will get the figure like this. Now we want to do the XY plane. So XY plane is plot 3D, open bracket, rho, theta pi over 2, where rho is equal to 2 to 5, theta equals to negative pi to pi, and the chords is spherical. Then we will get the figure like this for XY plane. Now we want to combine the display. So we use plot, open bracket, display, close bracket, open bracket, cylinder, hemisphere, XY plane, close bracket, and the viewpoint is circle left. Final output is like this, where this is the XY plane, the outside is the cylinder, and the inside is hemisphere. So that's all from me. Thank you.